Okay, the rest of 10-6, again, we're still talking about volume. We finished talking about how to find volume of rectangular prisms, and I think we did triangular prisms as well. So here is a challenge question for you if you want to, I think this is would be considered number 3 for you guys, if you want to try to figure out how to find the volume of this swimming pool. Okay, or actually the weight of the swimming pool. The second part is all about volume of cylinders. Again, cylinders are like prisms because they have two congruent bases, but it's easier, the formula is easier for cylinders because their bases will always be circles. So again, we told ourselves that to find the volume of something, what you do is you take the cross section, if you slice this can in half, you take the area of that one piece, which is congruent to the base. So you take the area of the base and you add up all the bases that fit inside that can, and that's considered the height. The height affects how many bases you can fit into that can or the cylinder. So the shortcut is to take the area. This capital B stands for the area of the base times the height of the whole cylinder. Okay, and something maybe you guys have noticed is that if I can say that it's a right cylinder, that means it looks like this stack of CDs. If you go from the top down to the other base, it would make, here's my other base, it would make a right angle. So this is called a right cylinder. Something is called oblique if it does not make a right angle. So if you go from the center of this base to the center of this base, you can see it does not make a right angle. So that's called oblique. However, this figure is considered slanted. So the height would really not be, would not be this. It would not be this line like it is in the right cylinder. It would be the distance from the top base to the bottom base. So this would be considered your height. Okay. All right. So for number 1, find the base area. We have a cylinder. Again, we want to find the volume. So to find the volume, the first thing you need to do is find the area of the base. So the base is a circle, so we know it's pi r squared. So you're going to put in 24 for the radius, so we have pi 24 squared. And 24 squared is 576. Leave it in terms of pi. So the base area is 576. So one cross section of this is going to be 576 pi's. And we have 33 inches of those. So what you do is take the base area and you multiply it by the height. So you take 576 and you multiply it by the height. So you take one section of one area, one slice of the base, excuse me, and you see how many times it fits in this 33 inches. So 576 times 33 is 19,008 pi's. That is your volume, inches cubed. Go ahead and try to find the surface area. Number 2, the only difference is this is an oblique. So they still give you the height. This is your height. The radius this time is not going to be 18. The radius is going to be 9. So go ahead and see if you can do number 2. Okay. Number 3, we'll talk about in class. Remind me to do this one in class and do this one in class. We'll talk about what happens to the volume when we change the sides. But I want to see if you can try to figure out number 5. Find the volume of the composite figure. This looks weird. Think of it like a donut. So you have an outer circle with the radius of 18. This is like if we were looking down on it. And then we have a smaller circle, okay, that's being cut out of the bigger circle. And the radius of this one is going to be 9 inches. So what you're going to do is find the volume of the bigger circle and subtract the volume of the smaller circle. I'm sorry, I don't know why I'm saying circle. Volume of the smaller cylinder. Okay, so remember, composite figures are when we have two figures pushed together. All right, that's it for volume for cylinders and prisms.